Now, the top and the bottom are the same. Yes or no? So this term will be 1 plus by 0. Okay. So you lock down the operating strain rate for this test that you're going to do. Okay. You use the reference strain rate. Okay. And then the next one, the theta. And you guys, I think, guess. So the theta is the operating temperature. Right, is also equal to the theta ambient. So you're going to carry out the test. So all tests in phase 1 are carried out at room temperature. Okay, room temperature. Okay, so you carry this test at room temperature. Okay, any questions so far? Does it make sense? Yes or no? Right. So when this is the case, right? When you do this, you isolate the strain rate effect, and you also isolate the temperature effect. Okay. Anyone? Any questions so far? Are we okay? Anyone?
Sorry. So are we just trying to determine what A, B, and N are in that equation?
Yes. That's why we lock down, we lock in the strain rate effect, and we not lock in, we neutralize or isolate the strain rate effect and the temperature effect. Okay.
We do that using mechanical tests, or
yes, so tensile tests.
Okay, so this would be done in the lab
at room temperature, and you use the reference strain rate. Okay. So when that's the case, okay, when that's the case, these are the data. So you carry out your test. So these are the data that you will get. Okay. So this is test 1, test 2, test 3. Okay, so this is your trial 1, trial 2. Okay. So when you get this, okay, you use stress. You can find. So the equation that you're going to fit this in is stress PL is equal to A plus by B epsilon PLN. Okay. So you can use Excel solver to determine A, B, and N. Okay. Next week I'll show you how to do it. Okay. So over here, why we did.
Hey Eugene.
Yes.
You also mentioned the Excel software for something way back. Is that something we might have to use during the midterm?
Yes. You know the solver in finding the goal seek. Okay, so if you go into week 2, I think it's week 2, I demonstrate, or week 1, I demonstrate how to use goal seek. Yes or no? Hello. Can you remember?
Yeah.
Right?
It was
So
week 2, I guess.
learn how to use.
I think it was week 2.
Week 2, right? So you have to learn how to use that. Okay, to find the epsilon optimum. Okay. So in this test, so test 1 or the phase 1, okay, 3 tests or 3 trials are required. Okay, you just don't do 1 curve. Okay, you have to do 3. Okay, so 3. Then in phase 2, so this is phase 1, this is done. Okay, so in phase 2, okay, the next phase you're going to do, which is the second most expensive, is the effect of thermal softening. Okay, effect of thermal softening. So over here, we are going to determine. Okay, over here, we are going to determine M. Okay, so now down here, we are going to do. This is done in phase 2. Okay, this is done in phase 2. Now, regarding this test, okay, what is the maximum? So we're going to plan different temperatures. Okay, so for example, we are going to plan theta 1, theta 2, okay, theta 3, and theta 4. Okay, or if you have to plan 3 levels, fine. You have to plan 4, fine. So theta 1, you already have already. Okay, theta 1 is your theta ambient. Right? You have times 3 tests. Okay, so this is done in phase 1. Okay, this is theta 1. The other temperature, right? What to choose, right? What temperature to select? So you have to be very intelligent in selecting the temperature. So what do I mean by intelligent? Again, okay, so varying the temperature is dependent on the maximum operating temperature during manufacturing. Okay, so what do I mean by that? If your theta max or theta operating or maximum, maximum operating temperature is 600 degrees C. Okay. So, any idea why 600? Anyone? Any idea why I picked 600? Where did 600 come from? Hello? Anyone, please?
Off the top of your head?
Off the top of my head, you please.
If I were to guess, I guess after 600 degrees Celsius, metal will start melting, maybe, or just aluminum.
So if your maximum of why 600 is dependent on machine 2 capability. Okay, what do I mean by that? If your equipment in your company only can heat up to 600 degrees C, yeah, that is 600. Don't go crazy, okay? If steel is 1400 degrees C melting, okay, let's do until 1400 the melting temperature of steel and get the mechanical point. Don't do that, okay? By the way, I was like that, okay? I don't want you to be as dumb as me before, okay? So yeah, don't do that, okay? You plan. If that's the maximum your company can operate in, that is your maximum temperature. Okay, so if you ask me what is theta 2, theta 3, so this will be you pick levels. So this will be equal to 1.0, okay, theta max. Maybe I do somewhere that is 0.6 theta max. And I do something over here like 0.4 theta max. Okay, you plan. Okay, you plan this. But the most important thing is, what is this theta max that you're heading for? Okay, so each test over here you do twice. Okay, you carry out twice. Okay, for each test. So what you do down here? So phase 2. Okay, phase 2. So 2, 4, 6, 6 trials are required. Now, the number I gave you is minimum, okay? If you want to do more, go ahead, knock yourself over, okay? But minimum, this is the minimum that you have to do. This is the minimum, okay? So phase 1 is 3 trials, phase 2 is 6. And the last one, which has poor repeatability, okay? The last one has poor repeat. It's well known. Okay, so phase 3.
Sorry, Eugene, later or next week, you're going to show us how to solve for these?
Yes, I'm going to help you how to find A, B, and N. Okay, so we will come up with a stress strain curve. Okay, so let's say we actually do an experiment. Then we'll come up with a method that can be done in Excel, okay, to determine what's A, B, and N. Okay, now, so phase 3 is to determine the effect of strain rate. Okay, once again, okay, I will repeat this test. Okay, what I said, it is the most expensive and have poor repeatability. Okay, so this is your final phase, phase 3. Okay, this is your phase 3. So we know that we are going to have 3 different levels of strain rate, right? So you got, so again, the same thing, okay? The maximum strain rate is dependent on the operating on the strain rate magnitude that will be used during manufacturing or doing any application. Okay, for this case, I'm saying manufacturing, maybe can be for something else. Okay, and the maximum strain rate for this case, and on the maximum strain rate attainable by the machine 2. Okay, so again, you test. Okay, so epsilon dot max epsilon dot max. You determine what is the maximum, okay? And this one, you have again 1.0. You multiply by 0.